I would like us to shift. We'll do this example on Monday, okay? But let's go ahead and shift. Okay? We want to show that the mean length of a car is 9 feet, so that would be mu equals 9. Yeah? You take a sample of 34 cars and find that in the sample, the mean was 8.8 with a standard deviation of 1.3. You guys, that 1.3 is describing the sample of 34 cars, so that is S. So, based off of this information, what are our hypotheses? My null will be the equal to, and my alternative would be not equal to. Okay, so given what we have here, no, you have a sample for every single one of these. The fact is we don't have a greater than or less than anywhere in the question. So we're not picking a side. We're not picking bigger or smaller. So that would be not equal to. You guys, in this case, should I be doing Z or T? T. And the minute I choose T, I no longer have a standard deviation I write down. Instead, I write down my degrees of freedom. Can somebody remind me how we figure out the degrees of freedom? N minus 1. So what are my degrees of freedom here? 33. I did not give you a level of significance. So what do we choose? We're going to let alpha equal 0.05. Great. So now I got to decide my shading. Is this going to be left-tailed, right-tailed, or two-tailed? Two-tailed, because I didn't pick greater than or less than, so it could be either one. Great, you guys are on this. And the combined area of those tails is that 0.05. Yeah? So both of them are 0.025. So now, to find that critical value, you cannot do inverse norm because you don't have a standard deviation. So instead, you're going to pick inverse T.
How do you choose if it's T or not?
Do you know the population standard deviation or the sample standard deviation? So this is... So because you don't know sigma. What are we getting? So okay, in this case we are, instead of doing a p-value method, we're going to use the traditional method. Okay, so now what we need to do is find the t of our sample. So let's go back to our calculators. We're going to hit stat arrow over to tests. Does anybody see anything that might be useful here? T-test, option number 2 that says T-test. Go ahead and select that one. Again, we have the summary stats, so we want to select stats. What should we put for mu 0? 9. X bar? S? N? Highlight the not equal to. Hit calculate. we get a t-statistic of negative 0.897. You guys, are you with me that might be where I just put that purple mark on my graph? Okay, so is that in the rejection region? No. All right, so if we're using this method, in this case, we're going to fail to reject, and we're going to say that negative 0.897 is not greater than the 0.2305, and it's not less than the negative 2.305. It's like it's not in that rejection region. If that kind of makes sense. If you just say negative, if you write it out, that is absolutely fine. If that's an easier way to make sense of it, because those symbols are kind of funny. Okay. So, in this case, it's kind of unclear what the claim is. I would say that we're trying to show that it's equal to 9, so the claim is that it's equal to 9. Okay? So we're not rejecting the claim, so my conclusion here might be with 5% significance, it's reasonable to say that the population mean car length is 9 feet. Gesundheit. All right. All right, so let's go ahead and basically today we're gonna mostly do some extra examples of tests. That some of those test problems that we were doing last week, and then yeah, it's just more practice doing the same old thing, and then we'll be done pretty much with a little bit of some extra stuff that I added into the notes after kids struggled with the homework last year. Okay, so Pepsi claims that cans are filled to 12 ounces. Suppose you take a sample of 40 cans and you get a mean of 11.89 ounces. You're given that the population standard deviation is 0.65 at the 10% level of significance, so that would be alpha equals 0.10. Determine if Pepsi is everybody with me so far? Okay, so are you guys with me that if I say filling the cans with less than 12 ounces, that would imply mu is less than 12? So my hypotheses that less than 12 does not have an equal to, so that's my alternative hypothesis. My null then would be that the mean is greater than or equal to 12, which is what Pepsi's claim is. No, Pepsi would not. Pepsi is saying fill to 12.
Oh, okay.
Okay. So next we're gonna determine the critical value and shade our regions. Okay. So you guys, no matter what, our center is 0. But so we ask ourselves essentially, is this going to be? We haven't really talked about it yet, but do you guys remember with confidence intervals, we had z intervals and we had t intervals. And the way we make that distinction, like how do I decide whether I'm using a z interval or a t interval? And that answer was, do I know this population standard deviation? In this particular case, we know sigma. If you know sigma, you choose a z interval. If it is a z interval, then you just make the standard deviation as 1 and you're using inverse norm to find these values. All right, which side, is this left-tailed, right-tailed, or two-tailed? A reminder that to decide our tail, we look at our alternative hypothesis. Our alternative hypothesis is, shouldn't underline because it makes it look, is less than, so we're shading left. And what area do I shade? 10%, because I choose my alpha is what, my significance level is what I shade. How do I find my critical value? Thoughts? Inverse norm. So go ahead and choose inverse norm. And I think you get 1.28, but I was sure when, is that what you got, Sam? Yeah. 1.282? Yeah. Okay. To find your p-value, stat, arrow over to test, finding the p-value, okay? Which one do you think we should pick? We're not going to choose one prop z-test because our test isn't about a proportion, okay? Our test is about a mean, so we want to pick the z-test that does means, which is the very first one, okay? So we're going to go ahead and hit enter for z-test. In this case, do we have the raw data or do we have the summary statistics? We have the summary stats. So you want to highlight stats. What am I going to fill in for that mu 0? No. No. You guys, it's asking the null hypothesis. What does our hypothesis say? That sub-zero is like the sub-zero of the null hypothesis as to what mu is equal to, and that is 12. So mu sub-zero would be 12. Okay, the next thing it asks for is sigma would be 0.65. And X bar is the 11.89. N is, and again, you want to make sure you have the less than one highlighted. Go down and hit calculate. Okay, and in this case, our p-value is equal to 0.142. Okay. In terms of making your decision about the null hypothesis, if you're using your p-value, you say, how does 0.142 compare to our alpha, our significance level? Is 0.142 greater than or less than alpha? It is greater than. Is everybody with me? If that is the case, we would fail to reject. So, if I'm not rejecting the claim, we can say at 10% significance, it is reasonable to say that the population mean amount of Pepsi is 12 ounces. That's the claim, right? Pepsi claimed 12 ounces, and we're not rejecting the claim in this case. That claim being that null hypothesis. Everybody good? All right. We skipped an example earlier that I would like to go back.
I think it's like test one.
Oh. Okay, I'll do this one next.
Oh,
That's fine.
so which one are we doing?
I'll do yeah. Let's do this one, the one that says test 1. And then now if you would like to check your hypotheses, go right ahead. And on the test, I tell you to say which one has the claim, so maybe writing that next to that one would be appropriate. Getting into that habit is a good habit. All right, so if you want to check, did you come up with the correct picture and critical value?
How did you get your Z value?
I did an inverse norm. 0 and 1. Because it's of the z's, not of the sample. Okay, so we're using the p-value method. You guys, so for my p-value, I got 0.0047.
Are you able to do like 0.005?
Yeah, that's fine. And so that is less than our alpha of 0.02. So what's our what do we do about the null? And reject. Okay. And okay. So should probably start your conclusion. I like to start with the level of significance every time with 2% significance. We can say the population mean test scores are higher than 80. How are you guys feeling on these tests? Do you want to work through? Yeah.
Do you ever get the p-value?
Yeah, so this is a z-test. So in this case, you would, like, so if I ask you to use the p-value method, this is your explanation. Okay? If I ask you to use the traditional method, your justification would be 2.60 is greater than 2.054. So you're either comparing your z-test statistic to your critical value,
Okay.
or you're comparing your p-value to alpha, but they will make the same decision every single time. Is everybody okay? All right. Let's do. Why don't you guys give. Why don't you guys give this one a try on your own? Okay, this is using the traditional method. And what I'll do is I'll give you guys a few minutes to write your hypotheses, then show my hypotheses. Then I'll give you a few minutes to do your, so you're going to do each section on your own, but you can check with me a little bit at a time. I'm kind of doing them in lots of different orders. We're doing the page that has 8.5 at the top. So if you would like to check your hypotheses against mine. Am I on the wrong one?
Yeah, we skipped one. Yeah.
This example. And we've already kind of started doing the hypotheses here. So go ahead and do your next piece here.
For n, would it be like all of the numbers added together, or is it like?
N is your sample size. So in this case, how many values are in my sample? 6.
For this?
Is that all you need to enter those numbers, or do you need to like get an average? Or just
So what you're going to end up doing to run the test, you need to know the average. But like those options, like when I go to run this test, this is going to end up being a t-test because I didn't give you any standard deviation, right? So when I go to do that t-test, this would be an example of when I would put in the raw data. So you would type right? Because that's what we have. And when you run the test, it'll tell you the mean and standard deviation and stuff. So, but what you need to do, this is an example of where you have to type the data into the into the lists. Does that make sense? All right. If you want to check your sampling distribution against mine.
For frequency, is that just one?
Always 1.
Okay.
I'm not going to, like theoretically, if I said, for instance, this 30 happened twice, this happened 4 times, etc., then we might use that frequency. But what we have is that the frequency of every item on that list was equal to 1.
So even though it's a t interval, the critical value will always be c.
Oh, no, those are definitely supposed to be T's. Thank you. All right, you guys? Reject or fail to reject? Fail to reject. Negative 0.156 is not in the rejection region. Where was my claim? The claim is
The equals 32.
the equals 32. Okay, so what's our, so
So that would use that for the U of 32 because it's a claim. Because 32.
it's why the claim will always be the boundary between the null and the alternative, but the null is always the one that has an equal to in any capacity. So the claim could be the null. The claim could be the alternative. The null always has the equal to, because it's like, it's the one we assume that boundary is true. So in this case, we would say with 10% significance. We can say it's reasonable. The population mean hours worked is 32. Okay, let's take 5. Let's do this. And then we'll take a break. So try this one completely on your own, and then I've got a little bit more instruction on the next one, and then you guys can start working through either start your labs or the homework, whichever one you want to do. So, those of you at home, check your answers against mine. Okay. Now, this last page of notes that I'm giving you guys, I'm giving you because of questions that formed last year when kids were working the homework. So the Unit 8 homework has some extra pieces of nuance that includes some topics from Unit 7 and Unit 8. So I kind of want to go through kind of what's going on there, okay? So, what I'd like us to do is kind of think through as I look at these graphs. And when I chose P, so if I'm using P, automatically my graph is a graph of z-scores. And for each of these, we're going to graph the sampling distribution, which I think I meant to do down here, but whatever, it's fine. And these sampling distributions were the same. So like, let's do this. So we're using 10% level of significance, right? Okay, for this graph, is it right-tailed, left-tailed, or two-tailed? Two-tailed. %, would mean that each tail is 0.05. Is everybody with me? And if I asked you what are the critical values, you guys would plug this into your calculator, you would get negative 1.645. Positive 1.645. That's what those two values would be. Now, in Unit 7, we talked about confidence intervals, yes? And so then what we did is we did plus. Our margin of error was equal to z times the square root of p hat q hat over n. Okay? And that z, if I asked you to find the sampling distribution for that z, what am I doing? I don't need to do this. You guys, that sampling distribution is that sampling distribution. They are the same one. Is everybody with me? Kind of getting that? Okay, so that means that my critical value is the same for 90% confidence and alpha equals 10%. Is everybody with me? Okay. However, how would my picture change for this graph? Still alpha equals 10%. Left-tailed or right-tailed? For this one.
We're using the hypothesis at the top, like the.
Yes.
Okay.
Each one of these is for the different sets of hypotheses. This one is left-tailed or right-tailed? Left, because of that alternative hypothesis. This is now 10%. So it has a different critical value. Is everybody with me? Okay, and I think we get 1.282 because that seems to be keep coming up. Okay, oh, I'm sorry, negative 1.282. So what would the confidence level be that goes with this tail? Well, when we do a confidence interval, right, it's two-sided, right? We have the plus and the minus. So what confidence level would go with this picture? Well, you have an imaginary 10% on this side too. Does that make sense? So this one would go with 80% confidence. Do you guys kind of see what I'm saying here? Okay, and so what happens is like they get the confidence intervals can be used to make conclusions in the exact same way that tests can be used to make conclusions. So for example, like if I do a confidence interval from my sample, let's go ahead and say my confidence interval for my sample for this test was 0.19 to 0.32, something like that. Okay? Can I say P is not, like if these are my possible values for P is not, 0.2 is in that interval, so I can't reject the null. Like they can you can make conclusions from confidence intervals about a hypothesis just in the same way that you can make a conclusion about a test. Okay? So, the biggest piece is recognizing like when you are, like they'll want to know what confidence level goes with this alpha and vice versa. So you want to go through, no matter what, the confidence interval is two-tailed. So that'll influence some of the questions. I think they're towards the end of the Unit 8 homework. And this was a topic that caused students a lot of problems last year, which is why I added it into the notes, okay? So understanding that your confidence level and if its test is two-sided, and your significance level will add to 1. But if it's a one-sided test, it's your confidence level and 2 times your significance level that would have to add to 1, okay? In other words, so for these ones, a 90% confidence would go with 10% significance. Or 95% confidence would go with 5% significance. But if it's a one-sided test, %90 confidence would go with 5% significance, because you would have 5% on each side. And that shows up in your homework. All right. From here, we're done with the notes. You have, like if I were to make like a checklist of what you guys need to do before spring break, it goes like this. If you have not finished Unit 7 lab, or the Unit 7 homework. Both of those things are due by midnight tonight. Okay? I know a lot of you already have some of these done because I looked while you guys were on break to kind of where you guys are, okay? All right. After that, you have Lab 8A, Lab 8B, Unit 8 homework. Then you have to take test number 3. Now, to take test number 3, you should expect 2 class periods. And it needs to be done before you go to spring break. Is everybody with me? Okay. So, if you're leaving for spring break early, you've got more work to do. You have to get this done more quickly. Okay? But there's like the rest of the week is going to be spent. You guys tell me what you want. If it's not up already, I think I might have only posted it to the second period class. I'll do it right now. The topics up for test 3 will be posted in Blackboard before you leave here today so that you know what to study. Okay? And your homework, like all of this is due when you take test 3. So if you're for instance, if you try to use the block periods next week to take the test, great. That means while you're taking the test, I'm putting in your homework and lab grades. Everything is due when you take the test. Any questions?
So wait, there's this week we just have to, like, that's not my
Mhm.
every week.
Do we have blocks next week?
We do have blocks next week.
Okay. And are they still Tuesday, Wednesday?
They're, as far as I know, they are Tuesday, Wednesday. And when I say due when you take the test, if you're taking the test over 2 days, they are due when you start the test, not. Does anybody have any questions for me? I know that pretty much every one of your teachers are giving tests next week. If you're doing something different from block day or Thursday, Friday, please reach out to me and tell me so I can prep for that appropriately.
What did they originally, like
It was originally scheduled for Thursday, Friday.
but did you move it to when, did you move it? Or?
No, so it's, in my head, it's scheduled for Thursday, Friday, but a whole lot of people,
Oh,
like,
right.
everyone, so, like, I move things around to make people able to. Does that make sense?
Yes.
Okay?